I brought these because I've heard the lights are pretty bad up here, so hope you all don't want to see my eyes during. No, I'm just kidding. I won't do that. I can totally deal with the lights. So my name is Anthony Eden. I am the founder of DNSimple. So we do DNS, domains, and SSL certificates. And today I want to talk to you a bit about the processes that we use inside of our company and how they allow us to do big things with a small team. So there's going to be three parts. One, I'm going to tell you a little bit about the history, about how these processes grew up. Next, I'll tell you about some of the processes that we actually use. And finally, I'll give you some tips on how you could start doing your own processes at your team or at your company if you're not yet doing them or if you're looking to maybe revamp them a little bit. So in the beginning of DNSimple, we were a small team. This was back in 2010. It was me and my brother. We launched the company because I frankly was tired of using GoDaddy. I was like, this sucks. I want to use something that's better. And I'd been doing domains and DNS for a long time. In fact, so long, I'm going to tell you a real quick story about this. Back in '99, I was with one of the first domain registrars during the deregulation of the .com. And we set everything up and launched. And we had a lot of traffic because this was just the start of the .com sort of opening up. And we had all this traffic running through one little server that was sitting on the floor in an art gallery, which is where I was working because the guy who launched this thing happened to also have an art gallery. And the server, after a couple days, was literally smoking. All right, and I was like, and there was traffic, and it was taking a long time to get requests, and I was like, what the hell is going on? I'm looking at the code. The code seems right. It was written in Java. This is back in the days, like before JSP even. I mean, this is like a long time ago. And I said, there's something going on wrong here. And I talked to my brother about it, who is actually a software engineer as opposed to me, who is a musician. And he said, well, take a look at your database. You might want to use indexes. And I said, indexes? What are those? So that's a short story, is adding some indexes helped quite a bit, which is to say, especially after the last talk, we all do things sometimes at the seat of our pants. And often we do things to solve the problems. But isn't it nice when we can actually be doing things with a little bit more comfortability? So making it so that we can be comfortable when things start to go wrong. And that's a lot about what my talk is today. So back in the beginning, we had no process. Everything was essentially ad hoc. I developed the applications, and my brother worked on developing chef recipes so that we could deploy this stuff. And that's how it went. And in terms of architecture, it was fairly random as well. We had a few VPSs on different networks because we were running DNS, and we wanted some different networks involved so we wouldn't be taking down one network went out. We had 4 name servers all running unicast. We had a single web server and a single database. And everything was completely ad hoc. And that actually worked. That got us to the point where we could launch the system. And it was fairly successful. We started getting a little bit of traffic, grew a little organically. And just so to add some perspective here, we're a bootstrap company. We took no money outside. It was all just, hey, let's build a business that's actually a decent business. I've been down the road of going the startup path, raising money and things like that. I didn't want to do that. I wanted to build a business that would be sustainable. So skip forward to 2012. We add one to the team. So we hire Simone Carletti, who is an application developer. I started working on a new DNS server that we were going to use because our old ones were starting to get a little tired. And it's written in Erlang. I love it. It's still operating today. It's fantastic. One of my favorite projects I've ever worked on. And then at this point, Simone comes in and he brings in Hubot into our chat room. And thus begins where we actually start doing chat ops. All right, so this is our first experiments. They basically can't do much of anything, but at least we can get a little bit of data back from a bot in our chat room. Things are starting to get a little bit more interesting. 2013, we deploy across a much larger network. At this point, we saw things were growing. We wanted to be prepared for what the future had. So we deployed an Anycast network across 5 data centers. We launched the Erlang name servers into initial production. And we also started thinking about what happens when we have outages. Because at this point, we had started to have a few cases where things went wrong on our network and systems went down. And so at this point, we created a Status Page IO account. The founder of Status Page is here today to talk to you, I believe, tomorrow about his stuff as well. So that was something that was really good for us. We put that in place. And it meant that we could actually start telling people when things were going wrong. So that was, again, at this point, though, the processes are still fairly ad hoc. We started writing down a few things when they happened repeatedly. We had sort of a process for dealing with system issues, sort of a way to write postmortems, but it was still kind of iffy. So 2014, though, I'm going to move here for a second to grab my water, is pretty much a big year for us in a lot of bad ways. 2014 was a very difficult year. So first of all, early in the year, my brother decides to leave the company. So we were 3, and now we're 2. All right? And this is a key person who was there from the beginning, who knew everything about how everything operated, and who, in many cases, was the only one who knew everything about how everything operated. So this was a catalyst for rapidly changing our operational processes, all right, and actually for developing and improving them, because up to this point, we hadn't really thought about what happens when one of the key people leaves. That was a mistake, all right? So it's something we started rectifying pretty quickly. We started hiring as well. So once Darren decided to leave, we added on 3 people very quickly, 2 who were focused on the operational side and another who was focused on the application side. And we started basically having more repos. We had our core repo, we had our operational repo, and then we created a business repo where we're going to start developing some of the business processes. And that year really started putting all of our processes to the test, because we sell SSL certificates, and this happened during the middle of the year. I'm sure all of you remember this. In a span of 7 days, I think we reissued something like 1,500 certificates through a process where we had never reissued certificates at all in the past. And it was extremely complicated, and it was essentially we had to come up with how are we going to take this thing we've never done and quickly turn it into a process so that we can actually deal with this flood of customers. And we had an upstream certificate authority that we had to deal with who also was not prepared for this. So it was challenging. But it started getting us into the mindset of let's put it down into a series of steps and see how we can actually do this repeatedly, because this probably won't be the last time we'll have to do this. We also introduced some automation to help out with this. It was still a mostly manual process, but at least collecting information from customers and notifying us and generating the emails that we had to send to our upstream provider was all done through automated processes. Then we had this at the end of the year. So essentially, my end of the year last year sucked beyond beliefs. I mean, pretty much anything that could go wrong did. And this was the biggest one. So we got DDoSed for a period of, depending on how you look at it, from 8 to 12 hours on Cyber Monday. And it was awful. It was awful. Basically, this was the final step that said, OK, we need to move away from, and we'd already started developing our incident response process, but we need to move away from relying just on the people, but adding people plus a well-understood process to deal with these types of things, plus third-party providers and how to work with them. And it was just, things became complicated enough that the ad hoc solutions that we might have been using were just not good enough anymore. So move forward to 2015. So we've added 2 more people. And in fact, when I said, if you saw what I wrote for my abstract for the talk, I said we were 7. We're actually 9 now. And we have over 17,000 customers. So we're at a point now where we are operating more and more like a company that has a very specific set of things it needs to do on a regular basis. So we automate what we can, and we document the other things that need to be done by humans. And so that's what I'm going to talk about next, is these specific things that we have documented that work for our business. So obviously, when we do DNS, we're an operations type company. Operations mean a lot to our customers because the minute that we fail at operations is the minute that they have an outage. All right. So the first and foremost thing that we've developed is an incident response plan, and it essentially has 4 main parts to it. First, assess what's happening, communicate with everyone, whether it be outside to customers or inside amongst the team, respond, and then document. So let's look at each of these steps. Assessing is about thinking before you act, all right? The first thing you have to do is actually determine, and this is text essentially straight out of our incident response plan. So mostly it affects our DNS system. Sometimes it can be our API and our applications, but normally when it happens, this is what we do. First, we determine the impact. Once we understand what the impact is, we have a threshold for what it requires to call up additional developers. And in our case, that means calling up everybody. Everybody who is, well, even if you're on a weird time zone, because we're also a distributed team, it doesn't matter. You come into a Google Hangout room, and we meet up. And essentially, our threshold is if we have a DNS outage that lasts more than 5 minutes, that's the threshold's been crossed. All right? And at this point, it's mostly any DNS outage, even a blip, brings everybody in. And then the actual written one says anything greater than 10 minutes, but it tends to be even more proactive than that. So we start the communication process. We have a minimum of one person whose sole responsibility is to communicate with customers. Because during any sort of outage, the ones that think about any outage recently, and the ones that piss you off the most are the ones where they don't tell you anything. You're like, hey, I'm your customer, what's going on? And it's crickets, radio silence, nothing. Those are the worst. So that we have, specifically we say, we will communicate, one member's responsible for this. They're going to post updates to Twitter, and they're also going to update our status page. Our update frequency starts at every 15 minutes, as long as things continue to change and adapt. And then if it's a longer outage, we may make that 30 minutes if nothing is changing. So there are certain cases where you just cannot, you're waiting on an upstream provider, you can't do anything. Obviously, in the future, you want to work around this type of problem, but often it happens. And for those cases, if it's going to be extensive, we might wait 30 minutes before posting an update. Next, we respond. And by responding, I mean, in this case, we go into action. So we've already looked at what the potential problem is, and we've already started communicating with our customers. And now our goal is to minimize the impact on the most number of customers possible. So it may not mean recovering fully. It means getting back to an operational state where as few people as possible see the outage. And then finally, once we've dealt with it, so actually this is still in the response pipe. So essentially, we triage. So we don't try to fix it with the perfect solution. We try to just triage it as if we are in an ER room and somebody's about to bleed out on the table. We got to fix the basic problem first, stop it from dying, and then we move on to the next step. All of the team members, whether or not they're really knowledgeable about how the systems work, throw out ideas. So when we're in the Google Hangout, everybody says, well, what if we do this? What if we do this? What if we do this? And they propose possible solutions. And then we consider all of those and we start acting upon them. For internal issues, our goal is lowest mean time to recovery. So I don't know if most of you have probably heard this term. I like the concept. The concept is instead of trying to be 100% reliable, try to be able to recover your systems in the shortest amount of time possible. So for our internal systems, we focus on that. And then for external issues, so these are systems where we depend on others, we essentially have to rely on contacting the third party and explaining to them the severity of the issue. All right? And then finally, we get into the documentation process. So any significant incident here results in a postmortem internally, usually within 24 hours. And we try to do an external postmortem on our blog within 3 days. Our postmortems follow a very simple outline. What happened? Why did it happen? How did we respond and recover? And how might we prevent similar issues in the future? We obviously didn't come up with this. We pulled this from a fairly standard base of incident responses and postmortems. But it works very well because it's very clear and allows people to follow. We're as open as possible with our customers about what happened. Some companies, well, most companies are not. We found that it's much better to be very clear and even to dive into technical details. After you've said the non-technical part, you go into the technical details. But that may be just because our audience is a highly technical audience. We focus on selling to developers and operators and not necessarily consumers. All right, so that was how we do our incident response. I want to talk a little bit about our on-call rotation as well. So, these are the processes that are already in place. And when I say processes, it's documented, but it's also part of just the experience of doing these things over and over again. You probably have a bunch of undocumented processes as well inside of your company, whether you know it or not. So our goal, and at the stage we're at, is to try to turn these into well-documented things. So on-call rotation. So for on-call rotation, everyone on the team is on call eventually. All right? So even if you're not extremely familiar with how our systems operate, everybody is on call and is on PagerDuty call rotation at some point. And the purpose is to follow the incident response plan. So if you're on call and shit starts to go south, you follow that plan. If it happens for more than 5 minutes, you bring in other people from the team. We're spread across several time zones, so sometimes somebody's going to be there on call who doesn't necessarily understand what's going on, but that's okay. That's why we have the incident response plan in place. We use a follow the sun rotation, so that is to say that if you are awake, it's your normal day, that's when you're going to have the pager. I'm not a big fan of being paged in the middle of the night, and I don't think anybody here is. And it's funny because when Andrew brought up how many of you are on pager and how many of you have to wake up at 3 a.m. in the morning, I said, oh, if you're having to wake up at 3 in the morning, you're doing it wrong. All right? You should have enough coverage so that you don't have to wake up at 3 in the morning unless things are really, really bad, like existential bad. All right? That's the only reason you should have to wake up at 3 in the morning. It does pose a bit of a challenge when we all come to the same location. We have company retreats several times a year, and that means we have to keep the pager on. But it's okay because we're all in the same location, so everybody just would have to get out of bed. It hasn't happened yet that we've had an outage while everybody's together in a time zone that we're not covered, but it could happen. One of the issues that you run into when you're doing on-call rotation is, okay, you're scheduled, but you're not available. You're going on vacation. I'm talking at a conference, whatever it might be. It's really simple. We have a general availability calendar in Google. So everybody, if they're going to be unavailable, they say either I have limited availability or no availability. And then they basically ask on Slack and say, can somebody take my slot that's in my time zone? Very simple process, all right? And it works out extremely well. And if nobody's there to take your slot, well, then you're on call. Too bad. You didn't plan far enough in advance. The reason we do the around basically the follow the sun, and the reason everybody is on pager duty is because it's very easy to get pager fatigue. That is, especially in situations where you might have several days where you have, let's say you have an outage, and then you have residual effects from that outage, which almost always happens. If you're not prepared for that, then you probably haven't ever really had a significant outage. Essentially, having one person on call during that time is not a good idea. You need to hand off the pager to others. Otherwise, that person on call may seriously do what the other guy did and say, I'm going on a long run and I'm never coming back. All right, so pager fatigue is bad. We do rotate at least every week right now. So basically, you're one person might be on for a week during normal comm periods, and then they're off for a week or two, and they don't touch the pager. In more severe periods, we might rotate more rapidly. So the next thing that we have to deal with is security policies. We take a lot of effort to think about how to secure various things in our systems. One of those is our personal device security policy. We actually have it written down. This is what you do with your iPhone or your Android device or your laptop to ensure that it stays secure. All right, it's simple, but at least it has a basic policy there, so anybody coming in can follow this and go, okay, well, at least I'm doing the basics. We also talk about application security. So we have a security page where security analysts can come in and submit with a signed or encrypted PGP email that, hey, there's an issue and things like that. And we actually have caught several small issues with that security page. If you don't have one yet, I highly recommend having one and being open about it. You don't have to like, give out rewards and things like that. For a lot of them, it's simply good enough to be on a list of people that you say, thank you for submitting something and helping us resolve it. You're going to get a lot of script kiddies, so you're going to have to deal with that after the fact, and like they're going to keep submitting bullshit things that some analyzing tool that they use that was on the web showed you, so you'll have to learn to filter those out. One of the things we were talking about doing recently is no longer accepting submissions unless they are at least signed by a PGP key, because I know most of them don't know how to sign an email with a PGP key. So any serious security analyst knows how to sign an email with a PGP key. We also have a security escalation policy. So that means when we do get a real issue that comes in, we have a policy for determining how important it is that we deal with it and how to escalate it into the development, into actual software development terms. And then we have, of course, a bunch of processes to deal with our system security, things like who's allowed to access which systems. Now, we take a policy where once you're part of the team, you pretty much have access to everything. So once we get your SSH public key, you have access to all the systems, and you're supposed to act responsible. But that's our policy. Yours may be different. That's how we do it amongst our team. We also track CVEs, so common vulnerabilities and exposures. You should be doing this for any bits of software that run inside your system. If you're not, then you might be missing something critical. Obviously, you should be running latest patched versions of things. Heartbleed was a great example of where we had a lot of trouble with that, because it turned out that during that transition, after my brother left and other people came in, we realized that we were running a non-supported version of Ubuntu. We were running like the 13 branch instead of the 12 or 14. And nobody patched the SSL libraries on 13. So we actually had to build our own patches, and it was a bit of a pain in the ass. So it's good to stay on versions of software that are actually supported, and then to stay up to date with CVEs as they come out. We also started a password rotation. It's funny how many administrative shared passwords are probably being used inside your company right now. It's a little scary. And so we started thinking, well, what can we do to rotate these? Look at which passwords are more critical or less. Like if somebody gets this password, they have the keys to the kingdom. That's a problem. So, and there are some cases where you just don't have an option. There are some older systems you might have to integrate with that don't give you an option other than to use a single account to access that system. I know it sounds unheard of, but the whole world has not yet moved to actual good security. And then finally, we have two-factor auth, and we have policies for using two-factor auth. Any system that offers it, we say enable two-factor auth, and here's how to use it, and things like that. So moving on, chat ops. So we do command and control in Slack. This is a simple example of somebody deploying something to production in Slack. All right, that's for the web app. We can control all of our, most of our systems from within Slack to at least do start, stop, restart, and deploy. And we get some feedback about it. We found that it's useful because it allows us to see what others are doing and also to do things in a quick and constrained fashion. So instead of having to worry about shelling into a bunch of machines, which is I've done in the past, this solves that problem by letting us hit batches of machines and do things like this. Now, if you're more advanced and you're having automated deployments, which we do for some of our systems, good on you. But in many cases, that's not an option. And our bot is named Steve McBots. I love him. He's the best. We also have this little Go thing that I wrote that allows us to remote control. That sits behind on each of the systems. It's a little app that can run and that can actually act as a remote control to various processes. And so that's how we have the bot communicate with the back-end systems. Since in many cases you don't have a standard way of doing this, we just built something that was very, very small and let us do the basic things that we wanted it to do. That's open source. You can look up Go Remote Control. It's really basic. We also document what we do for customer support. So at DNSimple, all of us do customer support. And it's kind of like a competition amongst the team. Who has the highest number of customer support responses during the month? And it's pretty funny. It's actually also a really great way to understand what is hurting your, what your customer pain points are. So this is just something I bring up because I really like this aspect. I know a lot of people say, well, if I'm doing customer support, then how can I do development? Or how can I be an operator and things like that? The fact is that if you're getting so much customer support that you can't do anything else, you might have a problem. All right? Maybe you should address those things that are coming and flooding your customer support service by doing things like putting up a wiki page, or not a wiki page, but some sort of page where people can get information on their own. For us, that's support.dnsimple.com. But really, it helps us identify the things that we need to do better at, whether it's from an operational standpoint or an application standpoint or a business standpoint. And we also document our business operations. So these, again, I'm talking about the idea of processes being a better way to operate your company, your team, your systems as a whole. It's a view of the entire ecosystem of how your company runs. All right? And we take it to the point of where our business operations are documented, things like onboarding, accounting, and things like that. And I'll talk in just a second about how to avoid being overloaded with processes, because that is a real risk. All right, our processes, we have essentially customer-centric processes for how the business runs. So this is how we deal with our customers when things go wrong. So for example, customer loses they change, somebody on their team quits the company, and they were the only ones that had access to the system, and we don't know what credit card they were using, and oh, we need access to the system now. All right, this is a perfect attack vector for social engineering. So having these processes in place and identifying the risks in advance help us avoid social engineering attacks. And I'm going to harp on security a little bit here just because we don't do enough of it. Right now, as a whole, the industry is trying to get better at security, but we still suck really bad. So if you are not identifying and preparing for social engineering security attacks because you think, oh, I'll make everything under HTTPS and that'll solve all of my problems, you're doing it wrong, all right? They're not going to attack you from there. Most security breaches come through social engineering or from inside companies, all right? So from bad actors inside the company. We also document our takedown policy. So this is rules, and this is made. These are customer facing, so these things that they see. What we'll do, like under what conditions we'll take down a site off of our system. We also have our refund policy. Under what conditions will we refund a customer who asks for it? And generally, it's almost all the time, unless they're really trying to screw us over somehow. We have team-centric policies. This is what I was saying before, onboarding policies. We do a peer review, so we do a quarterly peer review where everybody answers a few questions about themselves and everybody else on the team, and we use that to try to make our team better, all right? And then we have things like anti-harassment policy in the team already, which is, so I'll admit right here on stage, our team consists of all 20 to 30 or 35-year-old white guys, all right? That's a bad situation to be in, but we still need to deal with this early, like dealing with the fact that eventually we need to hire and diversify, and coming up with good anti-harassment policies and good hiring policies, that's one of the first steps. And then I mentioned bookkeeping and accounting, exit process, so what happens when somebody leaves the company. So all of these things are things that we've done. And now I'm going to go to the third step and talk about what you might be able to do to develop processes in your team or your company if you haven't already. So what makes a good process? The first thing is born from experience, all right? If you're yanking a process from somebody else's process documentation, it's okay as a starting point, but that's not a process that's designed from you. It's okay to borrow from others, but you need to tailor it for your team's needs, okay? And that's another important factor. It has to be created by the team that's using it, not by an outsider, not by a consultant, not by somebody in management if you have management. It has to be an effort from the team that actually has to abide by these things on a regular basis. Otherwise, it's doomed to basically failure. Nobody's going to follow it, or they're going to follow it piecemeal, and it's going to end up causing more problems than it's going to solve. I believe that a good process is written down and shared with everyone. So just because the team is creating that process doesn't necessarily mean that the team is the only one that should see that process. Everybody should be able to see it, at least inside the company. I think openness like this is good because you never know where somebody who is unexpectedly going to share something with you is going to go, oh yeah, we totally missed that. All right, so I think sharing is good, especially within the company. I also believe that if you're open to it, that sharing outside the company is good as well. It has to be concise. So this is one of those things to avoid getting like stamped down by processes. Overly lengthy processes are not going to be used. It needs to be a very concise number of steps, and it has to be clear. All right, because in times of duress, which is often when we will be dealing with these processes, we need a very clear guide that is short as possible. It also has to be malleable because in those times of duress, surprises are going to happen. So you're going to need to have some openness. And by keeping things concise and clear, it actually makes it more flexible for your team. All right, so, and your systems aren't going to stay the same. The system that you have this year is not going to be the system that you're going to have 2 years from now. So your processes need to evolve with that. And if they're not following the systems change, then, well, you're going to have problems. And it's guidance. Your team has to be able to act and adapt. So how do you get started? Simplest thing is start a wiki, all right? You can do that on GitHub right now. You can go in. It's free. It's not the best wiki software, but whatever. I can go in right now in GitHub and make a few pages of things that we see happening over and over again in the company and make that happen. This is the homepage to our business wiki over at DNSimple. So the first thing that you do once you have a place to put it, and it should be a place where it can be modified and worked with a little bit, is you look at what has happened in the past. You evaluate your history. You see where have we had to do ad hoc responses, and then you start saying, okay, that at the high level is something we ought to look at. All right. So for us, for example, it might be, okay, we've had 2 denial of service attacks. This is something that we should look at and figure out what was similar amongst those attacks and what did we do, what was successful to address it and what wasn't. The next is you just write down those events. I mean, it's silly. It seems so simple when I stand up here and say it, but there's so many times where things are going crazy and you get done and you're just like, man, I'm just so happy that's over. I need a beer later. And what you really should be doing, okay, I'm just going to write some quick notes in whatever, in Notepad or Evernote or in Vim. And at least I'm going to have something there. And then if it happens twice, it's a good candidate for codifying. So codifying is putting it down into permanent words, essentially. And if it had a major impact, even if it happened once, it's a good idea to codify it. Those are my simple rules. Next, write down a series of steps. All right, so you've got the event that happened. You wrote down, you said, these are the things that happened. Now, what are just the fewest number of steps that you can do to deal with it? I'll bring back up my incident response plan again. Okay, so we have to assess, we have to communicate, we have to respond, and we have to document. All right, that's the simplest. That's the simplest we could come up with. There's going to be time for details later, but you got to start with just saying, here's a little process. When I did things for the accounting side of the business, I said, okay, the process is download this report from one bank, download this from the credit card company, things like that, right? Just basically write down a series of steps. And finally, you have to start executing, all right? Preferably you do this in times where things are calm. Have a game day if you haven't done game days yet. Even we are remiss in not doing game days enough because we've had things happen in reality, in real time. That's not the best place to be testing these processes. Have a game day, try it out. But the main thing is good processes are one you're going to execute. If you're not executing it, you may not need that process anymore. You might want to put it in the dustbin. And then finally, prune it. So take out the stuff that doesn't work anymore. Write down new processes. The old ones don't work. And then automate where possible. So you're going to hear people talking about process today. The other side of the coin is the actual automation side, and one that I think is valuable as well, and that is the other part that makes small teams work. So ultimately, good processes are the things that will solve you in real-world events in times of duress. You should be wary of processes just for the sake of having processes. You're going down the wrong path if you go that direction. You're going down the right path if your processes are there when you need them the most. All right? When something goes wrong, when somebody does something bad in the company, or when an outside player does something bad to attack you, or whatever it might be, those are the times when those processes make the most sense. And with that, I'm going to end my talk. I'm not sure if we have time for questions. One question, and just so you know, here are all of the Flickr photos. I'll put this online afterwards. And then if you want, you can follow me on Twitter. We also blog about a lot of this crap up at blog.dnsimple.com. Feel free to come. And I'm always open to answer questions, Anthony at DNSimple.com. If you ever want to talk about this stuff, I love to talk about it. So feel free to either catch me here or just email me afterwards. And if there's one question from anybody, I will answer it. Yes, sir.
How do you guys address if you want to do that transfer from one person to another? Because we actually had our DNS hijacked, and we're shitting bricks for 5 days because we were worried that they were going to change DNS records. And then
Sure. So the question is, how do I avoid getting our DNS hijacked by using DNSimple or any other provider to make sure they've got a good process so that somebody else can't use that attack vector? And our answer is very simple. We have codes of like yellow, red, white as far as the impact that it'll have on somebody if we make a change. And there are certain things that fall into you will never do this in the team. One of those is we will never make a change like that on somebody's behalf. We will do everything in our power to help them get access so that they can make that change. And by everything in our power means like show them where they can get their forgotten password link. Show them where they can get their, how they can reset their two-factor auth using their lost auth code. But we won't turn off two-factor auth for them. It's really hard to get through without actually doing it yourself. And that's the way that we do it. And I don't think that there's any other solution because almost all the time, that's a result of somebody in customer support trying to be helpful and actually hurting you. So we've looked at those things and we've said, just aren't going to do it. Well, thank you very much.
Thank you.